In this lesson, you will learn how to simplify radicals with an index number of a 2. So when we're looking at radicals, this symbol is the operation of square root if the index number is a 2. Most often it is understood to be a 2 if there's not an index number there. The number inside that symbol is called a radicand. And that symbol is a radical symbol, so we will be simplifying these radicals with an index number today of a 2. Let's look at our first example. We have the square root of 20. We know this is a square root because there's an understood index number of a 2, so if you need to write it in there, you can, because it typically will not be shown with square roots. In order to simplify these, you will not type them into the calculator. You should never have a decimal answer when you're simplifying radicals. You will begin by doing prime factorization. So we'll begin with prime factorization of 20. We're going to divide by a prime number, and the prime numbers are 2, 3, 5, 7, and 11. There are more, but those are typically the ones you'll need. So divide by a prime. I typically like to start with the smallest prime, so I'm going to divide by 2. 2 goes into 20 10 times, and continue to divide by prime until you get to 1. So 2 goes into 10 5 times, and 5 is a prime, so it can divide into itself 1 time. So the prime factorization is 2 times 2 times 5. If you multiply those numbers back together, it does equal 20. So let's rewrite those prime factors under our radical sign. 2 times 2 times 5. It does not matter the order of those prime factors. I do recommend that you group the pairs together because that will be our next step. Finding pairs of like factors. And we're doing pairs because this is a square root and pairs mean 2. Later, if your index number is larger, like a 3 or a 4, you'll find groups of 3s and 4s. But today, we're only going to be finding pairs of like factors. So we have a pair of 2s and no other pairs. So we'll take that pair of 2s and write it on the outside of the radical as a 2. Think about it. 2 times 2 is 4, and taking the square root of 4 gives you a 2. That's why you write down a 2 and not a 4 outside of the radical, because you're actually taking the square root of that number. The 5 will stay inside the radical because it has no pairs, it has no friends, you could say, to go outside the radical with. So our simplified answer is 2 the square root of 5. You could check this with your calculator. To find the square root button, it's second, and then here on the x squared, how the square root button's in blue, you'll hit that button to get the square root of 20. Whatever that crazy decimal is, you don't need to write it down, but you can compare that with your answer 2 times the square root of 5. Notice how those answers do match, so you can assume that you have simplified correctly. Let's look at another example, number 2. Here we have the square root of 108. So again, start with your prime factorization. Choose a prime number. As long as any of these prime numbers will divide into 108, you can start with that value. I typically start with the smallest, but 3 will also go into 108. But I'm going to pick 2 because I prefer starting with the smallest prime number. 2 goes into 108 54 times. Notice this is the same division as you've done years ago. We've just flipped it over. Instead of 108 divided by 2, getting our 54 this way, we're doing it upside down because you never know how much room you'd need to grow. So this gives you plenty of space. Keep dividing by a prime, so I'm going to divide by 2 again. 2 goes into 54 27 times. Here I'm required to pick a new prime because 2 will no longer go into 27, so let's pick 3. 3 goes into 27 9 times. Continue dividing by prime until you get to the 1. So here we have a pair of 2s, so 2 times 2 is 4, and 3 times 3 times 3, all of that equals 27. So 27 times 4, you can always check to make sure all of that multiplies back together to give you your value, 108. Let's rewrite our prime factors under one radical. So we had 2 2s and 3 3s. And again, we're going to be looking for pairs of like factors because we have an understood index number of a 2. If you want to write it in, since this is a square root, you're going to look for pairs of like factors. Pairs mean 2. So I have a pair of 2s. I have a pair of 3s. They have friends, so they get to go outside and play. They have friends, so they get to go outside and play. You will just multiply those together. So the 2 comes out, the 3 comes out, they'll get multiplied. The square root, the 3 that does not have a friend, has to stay inside the house or stay inside the radical. 2 times 3 is 6, and of course the square root of 3 we need to keep because it did not have a partner or a friend to go outside and play. It has to stay in the house. Again, you could check this with your calculator, punching in the square root of 108, and then punching in 6 times the square root of 3 and seeing that those values do match. But you will not need those values when you're simplifying. This is the simplest forms. Let's look at number 3. Here we're going to take 6 times the square root of 50. This problem is no different, even though it has the value of 6 outside the radical. We're just still going to simplify the 50 with doing prime factorization, and then we'll deal with that 6 here in a moment. So starting with a prime, I divide by 2. You could pick any prime that goes into 50. You cannot pick 10. 10 is not prime. So 2 goes into 50 25 times. Dividing by another prime, 2 will not work. 3 will not work, so 5. 5 is the next prime. 5 goes into 25 5 times. Do not stop until you get to a 1. You have to continue dividing by primes until you do get to that 1. So write out your problem. Of course, keeping the 6 out front is still part of your problem. Rewriting the 50 as 2 times 5 times 5, because of course all of that multiplies to equal 50. So we're just replacing that 50 with those prime factors. 2 times 5 times 5. We will look for pairs once again because we are dealing with square root. It has an index of a 2 there. So we have a pair of 5s. Because they have a partner, because they have a friend to go outside and play with, it comes out. The 6, though, stays as part of the problem. So it's 6 times this 5 comes outside. 5 times 5 is 25, but notice we didn't write that on the outside because the square root of 25 equals 5. That's why you're going to just write the number that you circled. If you circle a pair of 5s, that's the number you write. The square root of 2 stays inside of our radical. So to simplify, we'll take 6 times 5, which is 30, and keep our square root of 2. Again, you can check that in the calculator to see that 6 times the square root of 50, whatever that crazy decimal number is, don't show it on your paper, you can just check it with your calculator, and 30 the square root of 2, let me type that in again, there's the 6 square root of 50, and 30 square root of 2, now that I typed it in correctly, they do match, so we can say we simplified correctly. Let's look at one more, number 4. Here we have 7 times the square root of 32. So again, go and do your prime factorization. Only dividing by a prime. So 2 goes into 32 16 times. Again, only divide by primes. 4 is not prime. 8 is not prime. Do not pick numbers other than prime numbers to do prime factorization. So 2 goes into 16. 2 goes into 8. Once again, you can only pick prime numbers. A lot of times here I find people trying to divide by 4. 4 is not prime, so you cannot divide by 4. You must continue dividing by primes. It is called prime factorization, so only need prime numbers that multiply together to give you that value. So 2 times 2 times 2 times 2 times 2, or 2 to the 5th power, and again, you can always check your prime factorization. 2 to the 5th power does give us 32. Take a moment to check that prime factorization before moving further. So we have 7 still on the outside. The square root of, we need 5 of those. So 1, 2, 3, 4, 5 of those 2's. Because our index number is a 2, it's understood to be a square root. We're going to find pairs. So have 1 pair of 2's here, 1 pair of 2's there. It doesn't matter which pairs you circle, as long as you're representing each pair. So 2 will be written down for the first pair, a 2 will be written down for the second pair, and of course don't forget to have the 7 that you had already on the outside. So 7 times 2 times 2 outside the radical, and you'll have a 2 that stays inside the radical. 7 times 2 is 14, times another 2 is 28. Again, just as the last ones, we can check this in the graphing in the calculator. It does not have to be a graphing calculator, just any calculator. 7 the square root of 32, and 28 the square root of 2, seeing that those do match, and so you can assume that you've simplified correctly.